everyone. Sorry for the struggles in the beginning. We had a little bit of a technical difficulty, but we're back on, and we'll be here for the rest of the hour. My name's Nikki, and this is my co-host Nick, and we have an awesome guest today, and her name is Chad. Chad is actually the DA for the compute team, right?
Yes.
Can you tell a little bit about what you do?
Sure.
And what you're going to be showing us today.
Thank you, Nikki. So, my name is Chad Schmutzer. I'm a developer advocate for the EC2 Spot team, which means I am the interface between how developers and customers are using the EC2 Spot service, how it's being used in integrations, how it's being used in their architectures, and making sure that what we're working on and feeding back into the feature set that we're releasing is in tune with what you need for using Spot and saving a ton of money. So, pleasure to be here.
Yeah. So we've got an exciting program for today. I think we're working on getting the audio turned up just a little bit. But I guess while we're waiting on that, we'll introduce a little bit about today's topic and what we're going to talk about, right? So we're talking about EC2 Spot, talking about how, in particular, we can save money with deploying our web apps. And I know that you've got some awesome content lined up. Is there anything else you think we want to talk about? Like maybe let's introduce EC2 Spot, right? Like what is it for those that may not be familiar with it?
Who should watch? Can you be any technical level to watch the stream, or?
Absolutely. If you're familiar with AWS in general, and some concepts like EC2 autoscaling, then you'll be perfectly fine.
And afterwards, all the code that you're going to write, are you going to post that to a GitHub that we can share?
Yep, it's in GitHub already.
Okay, so I'm going to share the link to that GitHub. Where is that GitHub?
Sure. So that would be right here.
And then also we just encourage interactivity and participation. Feel free to shout out anytime. Chad has specifically said to ask him the hard questions. So make sure you give him some really hard questions because we're really happy to have him here in the studio today, and we want to give him a hard time.
And again, this is a live interactive show. This is for you, the viewers. If you have questions, please just throw them out in chat, and we will be finding ways to weave those in and not dismantle Chad too much during the talk. But we'll get those questions forwarded along. So please get those in chat during the course of the show.
Just open it for a second.
Okay. All right. I'm gonna.
Okay. So today, what Chad's going to be doing is he's going to be building a web app that we want to launch behind a load balancer on an EC2 instance, but we want to launch it using both on-demand and EC2 Spot to maximize our cost savings. Okay, so if you're not familiar with AWS, I probably just said a lot of words that are confusing. So let's take a step back, and I'm going to kind of explain each piece before he gets into the meat of really what EC2 Spot is and why you should use it and what's the value. So when you're building a web app, right, you're going to host it somewhere in the cloud. So you might choose AWS, and if you do, and it's just a straight up regular web app, you probably want to use a virtual instance. So that's going to be EC2. That is our virtual instance service. You might want to put a load balancer in front of it to balance your traffic so that you can put multiple virtual instances behind it and one doesn't get slammed. And in this case, we have different kinds of EC2 instances available based on cost. And so one is called on-demand, means you're going to pay for that full time, you want that on-demand. And another one is EC2 Spot. And Chad's going to go into detail about what EC2 Spot is and why it's important and why you should use it.
Thanks, Nikki. So EC2 Spot is basically spare on-demand capacity, right? So all that capacity we have in our data centers that is ready for you to spin up at utility-based pricing, we've made available as Spot instances with steep discounts, up to 90% off of the on-demand pricing as Spot instances. So it's the ability to request access to our spare capacity at scale for steep discounts, and there's nothing else different about a Spot instance than an on-demand instance. You can simply request a Spot instance. If we have it, we give it to you. You can use it to run your applications, and in this case, we're going to talk about how you would use Spot instances in an EC2 autoscaling group behind a load balancer to deploy your web application.
All right, so I'm excited about this. I know you have an end-to-end demo that we're about to dive into. We're still waiting on some audio issues that we're trying to get past. But I think while we're going to look into that, maybe we should go over some more of the basics. So you mentioned that EC2 Spot instances are the same types of instances as traditional on-demand ones. Like when I say traditional, that's what most people think, right? Like I click provision an instance, it provisions, it's ready, and it shuts down when I choose to shut it down, right?
Yep.
And so we have multiple different types of instances. So we have type of instance by on-demand, reserved instances, and now Spot. Then we also have different classes of instances, I guess you would call them, right? So that are optimized around different workloads. So these are basically two different axes that you can permute to basically, for the customer, choose a particular intersection of those two properties to fit your workload specifically and the access patterns and the traffic for it, right?
Yep. And when it comes to Spot, you really want to think about being flexible, because our spare capacity fluctuates and changes, right? So all those instance types, sizes, and families you talked about, those are all in different demand and different types of instances, different availability zones. And so it's important with Spot to say, I'm flexible. I can use C3s, C4s, and C5s for my application, or C3 large, C3 extra large, C3 2 extra large for my application.
We have a hard question for you already.
Yes.
That you may or may not know the answer to.
Yes.
PokeChamp wants to know, how does this AWS service compare to Google Cloud App Engine? I don't know if they actually have a Spot.
They have preemptible VMs. They do. Spot instances have some significant advantages over them. You have 2 minutes notice when an instance is going to be interrupted. That's one of the major differences between Google VM preemptables.
How much notice do they give you?
Roughly 30 seconds, but that includes shutdown time, whereas AWS gives you the full 2 minutes and then shutdown. So you have full 2 minutes to do your work, wrap things up, and then you get the OS, a full clean OS shutdown.
And with respect to the how the user is notified of that shutdown time, if I were running a workload on my EC2 Spot instance, is this some sort of event that I can now detect based on the app and incorporate that into my application code to handle offloading state, something that's more persistent, so that I'm not losing my work?
Yes. So we give the interruption notice in 2 ways, both on the local EC2 metadata service, so you can query for it. You can write a while loop that just simply sleeps and looks to see, does that interruption notice appear? And it also appears as a CloudWatch event. So you can set up a CloudWatch event rule to capture that event, and then fire off a Lambda function, put a job in an SQS queue, save state, drain containers, drain connections from a load balancer, whatever you need to do to architect around that interruption notice.
Awesome. So Limu asks in chat, or IEMU, I don't know how to say your name, but yes, we are accepting questions, so throw those in the chat, and we'd love to get those answered. Chat, how's the audio doing? Does it sound any better, any worse? How we doing? Once we get the thumbs up from all of you, we'll move ahead with the presentation, but we want to make sure everything's good.
Just to reiterate one more time, if you're just joining, this is an interactive stream, and chat has explicitly said bring him the hard questions. So please feel free to challenge him today. We want to give him a hard time. Audio is better, but still not great.
Coming through loud and clear. Okay, definitely sounds a little bit better.
Okay, we'll continue to improve it.
Yeah, if you have any other feedback. Oh, okay, so.
Sounds good,
Sounds
actually.
good by Twitch Ganesh. Okay, awesome. So, the moment everyone's been waiting for, let's dive into the example today. How does that sound?
Yes, wonderful. So what we want to talk about is deploying a web application behind an application load balancer with a mix of on-demand and Spot instances.
Right.
So this is a very common pattern that we see customers adopting for using Spot to do 2 things. They want to scale to a level they've never been able to scale before.
Yeah.
But because Spot allows them to, because it's cheaper, but also just to save money off of their existing workloads. So it really
so these mixed instance solutions are the key to both saving money but also scaling.
Absolutely. And the reason for that is that if you want to scale, you need to be flexible, right? You need to be able to say, I can use these instance types and these families to power my workload, and let us figure out where that capacity is and save the money for you.
So can you walk us through just a little bit? Do you have an architecture diagram
I
or
do.
something that you can show? I'm going to pull up his laptop right now.
How's that coming through?
That's
Can we see
great.
that okay?
I think, yeah, we're good.
Okay, so what we're going to do here is we're going to use CloudFormation, and specifically the AWS CDK, to deploy some infrastructure that we'll then launch into. So the CDK and CloudFormation will deploy a VPC with 2 subnets that we will use for the application load balancer as well as the auto-scaling group. It will also deploy some IAM roles and things like that so that we can attach them to our instances. It will create security groups, and that way we can have everything sort of ready to go, and then we'll just use those resources to deploy the actual application and load balancer and auto-scaling group.
We have a question from Scarecrow,
Yep.
2120. Is it game servers? What is used for game servers, I guess.
You certainly could use Spot for game servers. You do want to keep in mind that at any point your instance can be interrupted, so you definitely need to consider how do I handle statefulness. If you have a long-running game session, may not be the best fit for Spot, right?
Yeah.
If you can't shut things down in that 2-minute window, it may not be the right fit.
Yeah.
Oh, another question. Did you say I can run ALB on Spot? Scarecrow 2120.
No, you can attach an application load balancer to an auto-scaling group, but the ALB itself will not be powered by Spot instances.
Awesome. And I have a question of my own. So you mentioned there in the beginning that we're going to be using the AWS CDK.
Yes.
So I know that we released that fairly recently, I think at the New York Summit.
Yep. A couple weeks ago.
What is that? Because I know lots of people have heard of it. It's made some waves. It works, in conjunction with CloudFormation. Can you talk a little bit about CDK? Like how is it going to be used in this example?
Okay, I'll talk a little bit about CDK. So CDK is the Cloud Development Kit. So he's got this nice architecture diagram here, right? And you're looking at it and you're like, okay, how do I, create this infrastructure and make sure I have version control with my infrastructure? We have this great handy dandy tool called CloudFormation, which is our provisioning engine, and it will actually provision all these resources out for you inside AWS so that you can mimic this same architecture in multiple AWS accounts. But CloudFormation has traditionally been difficult to write if you're not familiar. And we'll actually show you what the CloudFormation template looks like for this infrastructure. But CDK is a new release, a new dev tool release for AWS, where you can actually write CloudFormation in actual code. So we used to refer to CloudFormation as infrastructure as code, and CloudFormation is just a JSON or YAML object with all the resources outlined, but it's as code because it's not really code, right? CDK is infrastructure is code. And so Chad has actually written his CloudFormation template in the CDK as Python, and he's going to walk you through that today, and then he could do a couple things using the CLI tool to synthesize this into CloudFormation, directly deploy it, so it'll synthesize it into CloudFormation template, and then it will deploy it to the provisioning engine. He can do diff, so he can call CDK diff to see how his infrastructure differs from the one that's been deployed in case he comes in here and makes changes. So CDK is a really neat tool to use to write infrastructure and make sure you have version control of your infrastructure. If you haven't checked it out, I highly encourage it. I'm super passionate about it if you can't tell.
Yeah, I mean, Nikki hit all the points there. I think one way that I've heard it referred to is basically like when you have a CloudFormation template, it's it's like it's just a giant config file, right? It's just a bunch of properties, keys, and values. And then sometimes people want to think about how do I write this in a more like interpreted way, right? So it's like, what if I was rather than just having this giant config, what if I actually step by step was essentially writing like a blueprint for how these resources are spun up, which is kind of like how CloudFormation was pitched in the beginning, but then the user experience didn't necessarily match that. But CDK does that now, so
Yep.
I'm pumped to see it. So
Yeah, I mean, I'll start by showing the original CloudFormation template, if that's okay.
Okay, so tell us how many lines it is, because I
Yeah.
always like to know how many lines of CloudFormation compared to how many lines of CDK. It's a really fun comparison I like to do.
Looks like 275, and that's after my formatting has been enabled, right? So that's
That's a lot.
Yeah, took me quite a while. I ported this over to the CDK, so let's take a look at what this looks like here. We're sitting at 112 lines, but that's because I've got some special formatting in, and I was teaching myself the CDK while I was doing this, so it may not be the most concise method, but it's a lot smaller, and it's really simpler, much simpler than what I did before with CloudFormation.
I think just from like, again, like this is Python here, and it has like proper language highlighting. Like just from a visual perspective, this is so much easier for me to parse than config like YAML or JSON for CloudFormation
Agreed.
templates.
And remember, since it's in code, you can do things like a for loop if you're creating multiple of the same thing, and all kinds of all the things that you can do in code, you can do now and create infrastructure off of. So I think that's an incredible feature of the CDK.
Yep. So should I walk through this real quick?
Yeah, let's go top to bottom. So we described the architecture diagram, but let's actually point to like how like the individual components here in the architecture, and actually let's start from the top, right? So like we said again, CDK is a tool that developers can use. Looks here like you're importing it, so it's part of the SDK family here.
Yep.
Photo 3.
Yep.
Or maybe it's its own. It's not entirely sure. I think. Yeah, CDK seems to be its own.
It definitely is its own, so I'm importing the libraries that I'm going to rely on in this CDK app, basically EC2, which is the fundamental service that lets us spin up the VPC, creating some infrastructure. We'll use Cloud9, which is our IDE for maintaining and deploying infrastructure within an IDE environment. So what I do here is I simply set up a brand new VPC, so it's a fresh VPC in my account, and I'm asking for 2 availability zones. That way I can load balance across 2 availability zones and tap into all of that spare capacity that Spot will benefit from. Next, I'll spin up a Cloud9 environment in that VPC. I'll pick a T2 micro instance, and I'll simply point it at one of the subnets, the public subnets that the VPC code up here spun up for me. Questions? Or?
That's cool. So what are you going to do in that Cloud9 environment?
That's where we'll run this entire demonstration. So I'll actually use the CDK to deploy a VPC, launch a Cloud9 environment, and then I'll flip to the Cloud9 environment to actually run the demonstration itself.
That's super cool.
I mean, I just think, like, off the top of my head, this is super interesting because it's like, again, you get all the benefits of this being interpreted, right? So it's like, okay, you can just define a VPC as this variable name, and you know that these methods or these properties and all of the other pieces that you instantiate, like, of object VPC, it has these methods and properties, right? So you can instantiate multiple VPCs. You could have different names for all of this, but it's like, again, this is like how we write code, right? So it's you can follow all of that logic through, and it just seems like a more intuitive experience than the CDK, which is, again, it's like you have this like arcane scroll, and it's like, okay, here are all the specifications. Here's like my list of ingredients for the recipe, but it doesn't necessarily tell you. It's not intuitive how those are all interacting with one another. You just have to have either written it or like spend a lot of time reading it.
Yep.
But here you understand how the language runtime is going to interpret this. It's more in line with the way we think that these things are actually happening behind the scenes also.
Yep. In
that these things get spun up sequentially or in parallel or so on and so forth.
Yep, and it also amazed me at how it took care of dependencies for me. So with CloudFormation Native, you kind of have to make sure that you're having dependencies and saying what is important to be created before the others. Here, I can reference things and I don't have to build all that logic in.
That's awesome.
So it was quite easy. So I'm creating a security group that we will use for the instances, and this security group lives in this VPC, so I can simply point at this instance of VPC that I created. Another one for the load balancer itself. Then I created some security group rules, right? So effectively I'm opening port 80, TCP port 80 for my load balancer and for my instances, and allowing them to communicate with each other. And this is really for debugging. I have a load balancer that I will open to the world here, port 80 on IPv4 to the world, so that we can all access this load balancer that I'm going to spin up. After that, I'm setting up an instance role and an instance profile. And the reason that we're doing this is we're going to attach a managed policy for the SSM service, so the system manager service. And we're doing this because we're actually going to use SSM to run commands on our instances to generate load. We're going to spoof load so that we can watch the whole application spin up according to
that's so cool.
Stressing the application itself.
And so the ALB basically, when it detects more load, it's going to spin up some of those more Spot instances in that autoscaling group?
It's actually a CloudWatch alarm that gets attached to the autoscaling group itself that will look at aggregate CPU load. So we're gonna generate CPU load on the instances. It'll trigger a CloudWatch alarm, and it'll start adding instances to help mitigate and bring the average load down across the entire autoscaling group.
Sweet.
So that's pretty much it. After that, we will rely on the things that we're creating in the CDK, and so I'm spinning them out as CFN outputs. So each of these will be referenceable from the output section of my CloudFormation stack that this will launch, and I'll take these values and plug them into my configs, and we'll create those configs from these values.
Super cool. Very easy. So you have a lot of outputs here.
I do. I probably could have written a loop or something to spit these out, but I wanted to make it plain and easy to read here.
And so some of these you're just spitting out the names so you know what the names of things are and where to find them, right?
Well, we actually need them in the configs. So for example, Well,
How about like the Cloud9 environment?
Cloud9 is so that we know which one was created as a result of
That's
this.
what I was thinking.
Yeah, the rest of these though we actually will reference directly the security group names.
For other things.
Yes, the subnet IDs. We'll put those into our configs that we will then create
Okay.
resources from. But this one is sometimes users will have multiple Cloud9 environments and they'll end up using the wrong one. So we want to make sure that they're pointing at the right one here.
Right, so we want to spit it out.
Yep.
And so essentially, just if we were to break this into like two main halves, I guess, in this app.py file, all of the top half, like if you go above the core.cfn output,
Yep.
you're essentially just instantiating these in-memory objects that have a handful of keys and values. But by the nature of using CDK to do this, you can simply just designate under the CFN output in the second half, and just like it knows how to route all of those keys and values intelligently, essentially.
Yep.
So instead of again wrangling with a config file and all of this formatting, it's just like, hey, here are the values you want. Like the CDK handles all of that mapping, and then you just output them as the CloudFormation stack, or is that output, or does that provision directly, like in the bottom half, like when you do CFN out?
These are telling the CloudFormation stack to include these in the output values that the stack will output.
Okay.
So these are telling it to make sure that these values are easily, like I can find them if I dug around.
Yeah.
But by including them as outputs, they're just listed in the output section, and I can just remain on that page and grab the values.
Great.
Yeah. And so finally, we tell it to create this app and launch the entire stack. So we want to head towards the next section of going and launching this.
Yeah.
Good.
Nikki, we ready?
Yep.
Sweet.
Okay.
Just
So
answering a question.
sure. Anything for me or?
There was a question of if you can use the CDK on the new servers that were deployed in the Middle East.
In the Bahrain region.
Yeah.
I don't. Is CDK available there? Well, it would
it's just CloudFormation.
CloudFormation, right?
Yeah. If the region is accessible via the API, I believe it
Yeah.
is. I haven't tried it, but that's my understanding.
Again, for those that may not be familiar, we recently launched Bahrain as a new region. I think that was a few days ago,
We
right?
had a lot of people excited about that on Twitch.
Yeah, I know we've had specifically Fortnite players. All of you are very interested in having servers or points of presence that are closer to where you play. So hopefully that helps out your player experience.
On spot.
All right, cool. So
specifically.
you are
yeah.
running it around CDK synth,
Yep, I'm going to run the synth command, which will,
spit out his CloudFormation template.
yeah, so this is going to take my code and turn it into a CloudFormation template, and we can see how big it is compared to what I wrote in the CDK. And this is roughly equivalent to the original CloudFormation template that I wrote for this entire environment. Once I run the synth command and it shows me that I have valid code and everything looks good, I can actually go ahead and deploy with CDK deploy. And running CDK deploy will use my built-in environment variables for which region to launch in. It's going to ask me, are you sure you want to create some IAM roles and open up these ports? And yes, I am, because I wrote it. And
So just to clarify, you actually could have run CDK deploy directly, but you ran synth just so we could see that it actually spit out the correct CloudFormation template.
yes, one thing that I used to do in the past before CDK was I would create my CloudFormation template and then launch it and then wait for the error to happen, and then I would go back and say what went wrong.
Debug and then.
Yeah, this drastically reduced the amount of time that I have to do that with the synth command.
Cool.
So would it throw an error on synth if there's
If it
some
can't
sort of
synthesize it?
syntax error?
Yep,
on that?
yep. It would have said, "Hey, you've got a bug in your code, or you're
Or
missing
what
something."
if you're missing like a role or something?
I didn't see that it did that. I did not see that it was
Okay.
sort of checking to make sure that all
was
of my
actually
requirements
accurate.
were in place. But it would tell me if my code was incorrect and if I passed a bad value somewhere.
Yeah. And so this is really important, right? Because you touched on it, but like traditionally, if something is wrong with your CloudFormation stack, you may not know until you launch it, and then
Yep.
if one part of your deployment of the stack fails, or errors for one reason or
The
another,
whole thing
the entire
fails.
stack tears down, which is very convenient, right? You don't want 99% of your architecture to work with 1% of it not working. But from a time perspective, this can be a little painful sometimes because you may wait, and the last thing in your stack provision or the thing that may take the longest may be what fails. So
Right.
at least you have client-side detection on making sure the params you're passing in are proper in the CDK. That, at the very least, is like now available.
Yeah. Again, it saved me a ton of time with how I was creating the actual app itself and making sure that all of my parameters and values were in place. And yeah, I didn't even have to launch it until I was done because I just kept using the synth command.
Yeah.
And at that point, I knew it would create.
And so we're basically sitting here watching this provision all the necessary infrastructure and do that. And so if you don't do this or deploy over the console, I know or over the terminal, you can see that in the console itself, and it has
Yep.
all of this data visualized as well.
Yep, we can splint to that and take a look at it if that helps. Yep, so we can see I have my stack creation in process here, so I'm in my console, and I'm looking at the events rolling through. So these events correlate with the events coming through in my CLI, right? So we can see that as these are created, I can see them appearing in my console as well. So one thing that will happen is that the CDK, I asked it to deploy a Cloud9 environment, and that Cloud9 environment is actually deployed via another CloudFormation template. So it will spin up a second CloudFormation template as a dependency of my original one.
Wow. And you should see that in CloudFormation, right?
We should.
Like a second stack.
We should, and there it is. Yep. So there's a second stack that was launched from my first stack, and this is because the entire Cloud9 service is managed through CloudFormation templates.
Awesome.
Yep.
And then we should just be able to get into Cloud9 and spin up the IDE that was created.
Yep. So as soon as the rest of this finishes being deployed, and it should just be a few more minutes here, we'll be able to start using the environment itself. So I'll jump over to the Cloud9 window here so we can take a look and jump into the actual IDE, so that way we're already ready to go.
Nikki, do you want to just add the camera back on so that
Yep.
everyone can see we're not just... Yeah. There we go. All right, cool.
All right.
Sorry.
No, it's all good.
So, all right, so our stack creation is complete. Looks like it was successful. I've got the outputs here that I asked it to output, so I can see them both from the CLI, but I can also see the outputs in the CloudFormation console itself. So if I look at this and I reference the outputs, so here are the outputs that we will be using for this demonstration.
Great.
All right, so let's go ahead and jump into and open the IDE that we launched. So again, this is the Cloud9 IDE.
Awesome.
I'm going to use it to do this entire deployment. So on the bottom, I'll have a terminal that I'll have access to type commands, but I'll also have the ability to edit code inline through the IDE directly as well. So the very first thing I'm going to do is I'm going to actually clone the GitHub repo for the workshop that I'm running through. So let's go ahead and do that. Actually, you know what? I want to update the CLI first because I want to make sure that I'm running the latest version of the AWS CLI in my Cloud9 environment. So let's do that by running pip install -u AWS CLI. That way, I can make sure that no matter which API I hit, I will have access to all the latest features and services that AWS has released via the API. Second thing we'll do then is I'm going to install JQ, and I want JQ because I'm going to use it. I need to look up the latest version of the Amazon Linux AMI, and I'm going to use JQ for that. So I'm going to go ahead and install JQ here as well. Making sense so far? Everybody following?
Yeah.
All right, so next thing I'm going to do is I'm going to clone the GitHub repo for the workshop that we're cloning this from, and this also happens to have the CDK that the URL that I linked you to earlier, Nikki. Hopefully that people can see
I
that.
did post that URL,
Okay.
the GitHub. I'm going to post it one more time since you just mentioned it.
Okay.
So this does have the CDK code that he was showing that he deployed.
So if you want to follow along, you're welcome to and clone this yourself.
Yeah,
but-
you could take his CDK code and just deploy it directly to your AWS account as well.
Yep. And so what we'll do here is we'll go ahead and change directories into this environment. So I can see in the bottom I've got an environment that has some pre-configured configs that we will then modify to use to launch our environment. And we can see that I also have access to this directory on the structure on the left. And in this directory structure, we have our files that we will manipulate. So, very first thing that we're going to do is we're going to create a launch template. So hopefully everybody online is familiar with launch templates. If they're not, EC2 launch templates are a way to templatize familiar configuration parameters for launching EC2 instances and resources. So many of the AWS services are adopting launch templates as a way to templatize and make it much simpler to pass familiar parameters, AMI ID, security groups, instance profiles, things like this that are always common. You want to stash them in a launch template and then use that launch template to create your resources. So what I'm going to do is I'm going to edit this launch template config here. Is my font big enough? Online, are we good?
Maybe a little bigger.
Yeah, and maybe just pull down the term. Yeah.
How is that looking? Is that coming through?
I
okay?
think that's better. Yeah.
Okay.
Yeah.
Let me know if you can't read this, everyone. This is a launch template config, and in this launch template config, I have things that I will use that I want to be associated with my EC2 instances. I have my instance profile, I have my AMI ID, I have my security groups, I have my tags. If I put my tags in my launch template, I can make sure that these tags are always applied to any instance that is launched as a result of using the launch template. So it helps me parameterize things, it helps me make sure that I'm following best practices.
So when you created this Cloud9 environment with the CDK, you copied over files to it already?
I did a
Cloned the repo.
Oh, we cloned the repo.
cloned
Sorry,
it
I
a
missed
repo.
that part.
No, it's okay.
Yeah, sorry.
So yeah, just again to catch everyone up, because I know some people are just joining us, we have looked through the CDK and the CloudFormation template that it generates. Using the CDK, actually, we can directly provision our CloudFormation stack that we have available here.
Provisioned 2 stacks actually, one for Cloud9 and the other one with the load balancers and the instance.
Yep.
And now we are in Cloud9, where we've cloned the application code from the repo that we had copied in chat just a few minutes ago. So that's where we're at here.
Yep. So I'm going to edit the file, and I'm going to actually insert some of the resources from the outputs that we made as a result of launching the CDK stack originally. So the first thing we want to do is attach the instance profile. So this is an IAM profile that gets associated with every EC2 instance that gets launched as a result of using this launch template.
Got it, and we created that with the CDK.
Yep, we sure did.
Yep, there it is.
There it is. So the second thing we're going to do is we need to grab the latest AMI ID. And what I like to do is I like to run this simple command here that will actually query, describe images, and spit out the latest AMI ID. And this is the reason that we installed JQ.
Wow.
So we're actually using JQ to grab the JSON, format the JSON, and give me the latest AMI ID. This way, no matter who runs this, whenever you run it, you always have the freshest and latest version of the Amazon Linux 2 AMI ID. So I'm going to stick that into my launch template. Next thing I'll need to do is to
Grab one of the security groups that we created.
Yep, exactly. So that's
The instance one,
the instance
right?
security group is right here in my CloudFormation stack outputs. I'm going to copy that, come back over and copy it into my code, into my config. Okay, now I also have in here user data, right? And this user data, in a launch template, it's required to be base64 encoded. So I've already done that and stuck it into the launch template, but we can look at the original. Let me save this real quick. We can look at the original text that was in the user data, and this is quite simple. This is my web application that I'm going to be running. First thing we're going to do is we're going to update all the packages, and we're going to install HTTPD and curl. We're going to install the Linux EPEL extras repository. We're going to install the stress package, stress-ng, and we're going to create a static HTML file that will simply spit out the fact that it's alive. We'll query the instance ID, and we will put that all into the index.html file. And that way, we have a very simple HTTP environment running on each of our EC2 instances.
So we actually have one question from chat. This is from TechNanner. So they're wondering, could you have used the CDK to run the git clone commands, or essentially like, so the git clone command for the Cloud9 environment, can we have done that through the CDK?
I believe that the Cloud9 stack will only support pulling from a AWS code commit repo for seeding code inside of it. Nikki, I don't know if you know otherwise, but I believe you can't pull from a public GitHub repo automatically on launch of a Cloud9 environment. I believe it's only code commit.
Unless it was a CloudFormation, so if you could do it in CloudFormation, you could do it in CDK. So if it was like a parameter in CloudFormation where you could pass it something to clone into the environment when you create, I'm not actually sure.
Yeah, I mean, I know there are EC2 like startup scripts you could define, but that's separate from a interaction between Cloud9 and another AWS entity or service. So
Right.
Yeah, it sounds like the answer is most likely just from code commit.
Yes.
But otherwise, the world is your oyster for startup scripts in your own environment.
Yep,
So.
exactly. So what we'll do now is we'll actually create that launch template from the CLI that we just modified and saved here. So I've saved this, and I will now run EC2 AWS EC2 create launch template, and I'm going to pass this config that I just created, and now I've got my launch template saved in my environment, and I can now reference this launch template for creating my auto-scaling group.
And so again, this is super critical because when we're having an auto-scaling group of Spot instances, we're expecting those instances to not be permanent, right? Like, we need to have a programmatic way to be able to have these automatically inherit all of these properties, like the security group from the launch template.
Yep.
Otherwise, every time it's been, otherwise, it's not like long-running EC2 on-demand instances where you may be able to manually provision this once or twice, but once it's auto-scaling, you need it to completely be automated. Otherwise, it defeats the purpose.
Yeah, and best practice for any auto-scaling group, though, would be to be able to bootstrap and automate the entire provisioning of any instance that the auto-scaling group adds. If you're going to scale up and add capacity, you want all of that to happen automatically as a result of scaling up.
Auto-scaling is only as good as the bottleneck, right? So
Yep.
if it's automatic until it's not, and you have to keep addressing that, then you're not really getting the full value proposition of auto-scaling.
Absolutely. And many customers will use auto-scaling groups for simply maintaining capacity as well, but it's still critical to automate the bootstrapping of your resources within your auto-scaling group.
There was a question about the latest Linux AMI.
Yep.
M3 Tallstorm, why does the latest AWS Linux 2 AMI have a 30 gig EBS boot disk as the default? Why does it need to be so big? When you create a T3 Nano costing $4 a month, you're paying $3 in storage costs onto it, which is a bit disproportionate. I don't know if you know the answer to that one.
I don't know why the logic for the default's there. Happy to ask that question and get it back somewhere, but I don't know the answer to the default question there. All right, so I'm just going to quickly confirm that my user data looks sound in my environment, and we'll do that by describing the user data from my launch template, and we can see that sure enough I have my commands here that are ready to be run when my instances are launched. Everybody following?
Yep.
Looking
Yeah.
good? Okay.
Anybody confused in chat, now's the time to ask a question.
Please do. I'm going to start powering forward here. All right, so next steps are to launch and create an elastic load balancer. So this is going to be an application load balancer. So again, I have a config here, application load balancer config, the JSON config here that is mostly defined. And I'm going to go in and I'm going to fill in the values from the CDK stack that we launched and
Yep.
place them into my config and create this environment. So the first two values I need are my public subnets. This
Okay.
way the application load balancer can put endpoints into my subnets in my VPC. So let's grab the outputs of public subnet 1. And public subnet 2 right here.
And so, while you're filling these values in, essentially we're just managing the handoff here between the application level code and the actual infrastructure that we provisioned using the CDK. So, we're going to get into exactly how the application works and everything, but a lot of this is cross-applicable to any sort of application that would use all of these different features or services rather, right?
Yep. So what I did earlier was I created a bunch of things that I wanted to shortcut to be able to show this quickly.
Mm-hmm.
And so it's a thin line between automating everything and then not being able to show the users what's happening. And so I'm pulling up the relevant configs that are really relevant to understanding how would I adopt Spot and attach it to a load balancer and make it all work, and not showing you how to create IAM roles, for example.
Yeah.
So I've now modified my application load balancer config, and I'm going to go ahead and create it. And we'll do this all from the CLI from within my Cloud9 IDE.
And then that was it.
Yep, that was it. So I've got the output of my environment. I've created a new load balancer. It's automatically provisioned it for me. It's put it into the 2 availability zones in my 2 subnets that were made for me as a result of the CDK. And now I can start using it. I can start attaching target groups to it and things like that. So we'll move on to our next step here, which would be basically creating a target group. And a target group is a place where you can attach resources. So we're going to create a target group, attach that target group to our application load balancer, and then we're going to create an auto-scaling group and attach that to our target group. That way the application load balancer knows where to send its HTTP requests to the applications living in the auto-scaling group.
Got it.
And so the benefit of that is that with the load balancer, you assign it a target group, which can essentially have a dedicated or static ARN or identifier,
Yep.
such that when you want to modify what is within that target group, in this case, either adding EC2 auto scaling spot group, or it could be anything else, you actually don't need to change that interaction between the load balancer and the resource group because
Right.
that's already handled and it's static.
Yep, I can quickly attach resources to it, subtract resources from it, and it's going to connect everything for me automatically.
So you can pass on that feedback to the EC2 service team, right? About the EBS
Default value for
being larger than it needs to be.
Absolutely. Yep. I need to make a note of that here.
M3 Tall Storm. He's going to pass on that feedback.
Metal
for you directly.
Storm. Come on.
Oh, Metal Storm. Sorry.
We will pass that on. Thank you for that feedback, Metal Storm.
All right. So in my target group, the only
It's a backwards E.
the only config I need to make sure that I have in my target group is the VPC itself. That way, the target group is associated with this VPC that I'm going to create here. So I've saved my target group config, and I'm going to go ahead and create
Run the
that as well.
command.
Yep, I'm going to run the command. Okay, so I've created a brand new target group. I have an ARN for it, and it's ready to go. So I can start using these resources with my application. So we've got that. Finally, let's create a listener. And the listener is really going to be, hey, what port am I going to listen on, and what am I going to listen for, and where will I pass those resources? So I'm going to edit the listener config. And the listener config needs 2 things. It needs,
The load balancer,
yep, you got it, the load balancer ARN and the target group ARN. And
which
I have
was spit out in your terminal.
It sure was. So I'm going to scroll up here, get my load balancer ARM, so it's ready for me to grab.
Yeah, it's right there.
It's right there. I'm going to stick it in. Oops.
And the target group was also in your terminal. I
Yep,
think.
it was in my terminal, and it's right here. So thanks for the IDE for keeping my history easy to access. And I'm going to save this in here. All right, so now we've got a brand new listener config. I'm going to save it. I've told it protocol HTTP port 80 and to simply forward those requests to this particular target group. Make sense?
Yep.
All right, so let's go ahead and create this target group. I'll grab this command here.
And we're good.
Listener is created and we're ready to go. So all of this again is available in my AWS environment, but I like to use the CLI, and we'll take a look at it here in a second. So now is the bread and butter of what we've come here for today, right? Which is to create the auto scaling group and understand how we can mix and match both instance, not only different instance types, but also spot and on demand in the same auto scaling group.
We've got one more question from chat before we go forward. I don't
Yep.
want to interrupt you midway. So
Yep.
TechNetter asked a great question. So what was the reason why we would use Cloud9 to be issuing all these commands versus using, let's say, like our local CLI for provisioning like the load balancer and all these other things?
Yep. So when I do this in a large-scale workshop, so I run workshops for large amounts of people, maybe at reInvent or at the Loft or just in customer environments. It's a much easier place to have a consistent environment that has permissions built into it.
Yep.
It has the CLI built into it, the AWS CLI. It has a lot of packages that are being
A
used.
pre-configured environment.
Yep.
Yeah, I think the other thing is like most of the issues that people get when trying to run these applications locally is that they're unaware of the things that will cause problems, and then you run into these unique bugs that are really hard to like get past because they're not necessarily inherent to the project, but rather like how remnants on your existing environment interact with them.
Yep.
And so using Cloud9 environment, you can just provision it, it's fresh, you know exactly what's on there, and more importantly, you don't know what's not on there. You know, like, and a lot of times that is what will block people when they're trying to reproduce sort of these like tutorials.
Yeah, getting a dev environment set up can also take a lot of time sometimes. So
yeah,
this is just an easy way to have one already ready to go.
Yep.
Out of the box.
Sometimes people will bring a Mac, a Windows machine, their iPad, and they all want to understand how to get the CLI installed.
And the beauty here is, you know, you make your Cloud9 environment, and then you can access that environment from any device, right? Because it's just standardized. And so, like, I could use this computer, I could use any other computer, regardless of OS or anything else that's going on there.
That's right.
And I know that my environment is controlled for and only accessed by me.
Yep. So I've now pulled up the autoscaling group config. If you only take away one thing from this session, I hope it's this, right? So this is an autoscaling group that is using a very recent feature, came out at reInvent last year, which in this feature is called the mixed instances policy, right? The mixed instances policy is where you can allow an autoscaling group to tap into multiple instance types, multiple sizes, as well as mixing and matching spot and on-demand in the same autoscaling group. This is a very powerful feature. It's a feature that customers have asked for a long time, and it solves a lot of problems. It helps keep a baseline amount of capacity online if you need that for your application, but it also helps you scale with spot around it. And again, this is where you're going to do two things. You're going to scale to levels you've never been able to scale before, but you're also going to save at levels you've never been able to save before. So let's kind of walk through this config here. First thing is we're using a launch template. So launch templates are requirements for using mixed instances policy. So this is why I created a launch template in the beginning. I wanted everybody to see how that works and why you need it. So this launch template is going to pass on the values so that I don't have to put them into my ASG config, right?
Nice.
So I'm referencing this launch template, and it's going to pass the AMI ID, the tags, the roles for the instances, the security groups, all these things that I would normally have to stick in a launch config or something like that are now stashed in my launch template, and I can get to the heart of what I want to look at. Next thing, the override section. The override section is where I tell the autoscaling group which instance types you're able to use. So the autoscaling group can be flexible across all the different instance types I stick in my overrides.
And it's going to create the bigger ones when the traffic is getting heavy.
It's actually going to allocate based on an allocation strategy that I've defined here.
I was going to say, like, how do you determine scale out versus scale up?
Yeah,
or like, what is that optimization point? Because I know that's its own entire class of, you know.
Yeah. So it's a critical point here. So today, an autoscaling group treats each instance as equal capacity. So
Okay.
what I've done here is I've stuck with instances that are similarly sized, right?
Yes.
Larges and then the T3 medium. They all provide very similar CPU and memory ratios.
Okay.
And that's what's important to me in my application. So understand that if you mix and matched different sizes in an autoscaling group, it would not distinguish between the two today. Right? We're working on adding functionality to allow you to say, this instance is providing this amount of weight versus this instance. And
Got
that way
it.
it can be smarter about how it provisions capacity. Today, though, in this
They all
live,
treats them all equal.
treats them all the same. So I've selected purposely instances that are very similarly sized. And now performance, an M5 large is a bit faster than an M4 large. A C5 large a bit faster than a C3 large. However, they're good enough for my web application. It's very basic. So I've told it that I can use all of these. Now, how do we tell the autoscaling group which priority to give or how to allocate these instances? So there's two sections here, right? There's an on-demand allocation strategy, which I've set to prioritized, and there's a spot allocation strategy, which I've set to lowest price.
Oh.
All right, so why did I do this? If I have a set of reserved instances, RIs in my account, and I would like the on-demand distribution to be focused on those, if I set this to prioritized, which is actually the only value available today, it will use the order of the overrides. So
So C4 large is first.
for on-demand, C4 large is first. So the auto-scaling group will use C4 large for as much of the on-demand capacity as it can. If at some point it couldn't get any more C4 large, it would move over to C5 large, but it will try to do C4 large as much as it possibly can for my application.
And this makes sense, right? Because like when you have an on-demand server that's provisioned, you're already paying a flat rate per unit of time for it. And so you want to make sure that that is reaching as much utilization as possible
Yep.
before you want to provision new infrastructure.
Yep. So the auto-scaling group will allow you to focus on your RIs in the on-demand section.
So when there's a spot instance available, it's going to go for the lowest price.
Yep. So I've set up the allocation strategy for spot to be lowest price, diversified over the 4 cheapest pools. Right. So what does this mean? I've listed 1, 2, 3, 4, 5, 6 instance types,
Yes.
and I've asked it, please use the 4 cheapest of those 6 as the baseline. So it will find the 4 cheapest of these 6 per availability zone and distribute round robin across those as best as it can. It can still use the 5th and 6th instance types if it needs to get the capacity, but it will try to focus on the 4 cheapest.
Right, it's going to go for the 4 first.
Yep. So on top of that, I've also asked it to have a base capacity of 2 for my on-demand, which means I would like the first 2 instances always to be on demand. That's the amount of instances I need to keep the lights on in my application. So that meant even if I couldn't get any spot capacity,
I always need 2
I always need 2 on demand for my application.
And this comes down to understanding your application's requirements, right?
Absolutely.
So like when you have variable traffic, you may have, like let's say you're located in one geo, and like when people are awake, it peaks at a certain time and they all go to sleep, and it doesn't go to 0, but it becomes, much more minimal. And so if you know that minimum point is not no traffic at all, like there's a certain floor that you will work out and ascertain like what your minimum capacity would be.
Yep.
So you can't really scale down to 0 unless your traffic ever completely scales down to 0.
Yeah, and I set it equal to my minimum size here of my auto-scaling group, because I said the first 2 should always be on demand. This is completely up to you, and some customers will be 100% spot. Now, it's important to understand, the more instance types I provide in my overrides, the more access I have to spare capacity.
Right.
So the more likelihood I'll be able to maintain my spot capacity that I've asked for. All right. How are we doing on time, by the way?
Minimum size is 2 instances are always
I'll
going to be
get to
running,
that.
and then max is going to be 12.
Yep.
That would
And-
be like 2 of each instance type, or how is that distributed?
Well, we'll see that it will first, and we can watch it, it will first pick the 2 instances for on-demand from this ordering.
Right.
So,
C4 and C5 large.
yep. So it'll do one C4 in one AZ and one C4 in the other AZ, and those are the first 2.
Okay.
Because auto-scaling groups strive to maintain capacity across AZs
Right.
for high availability. After that, I've asked for 0 amount of on-demand above the baseline 2, and everything else should be spot. So when I first launched this, I've asked for 4 total instances. I will have 2 on-demand instances and 2 spot instances.
As for time, I don't think there's a stream right after us, so
We're good?
We're good on time. Yeah.
Okay, all right. Well, I'm going to keep going here. I need to plug in the target group ARN and the 2 subnet IDs from my CloudFormation output here. I'm going to grab these 2 subnet IDs first. Now, keep in mind that spot best practices again include being flexible, and it's important to understand that flexible means not only selecting multiple instance types, but also using multiple availability zones, right? We've created a dimension here, which is instance types times AZs equals pools of capacity. So
Okay.
spare
So
pools
it
of
scales
capacity.
essentially linearly, because now you're like, if you go from 1 to 2 AZs, you're accessing double the amount of available servers or instances. And so that was actually as easy as under the in the CDK code, we just said AZs equals 2.
Yep.
And that's the only difference we needed to do. So you can easily just increase your available pool there, right?
Yep. You should make that number as high as you can per the region that you're operating in. I made
Awesome.
it 2 for simplicity, but for spot best practices, this should be as many AZs as possible in your region that you're operating in. The reason for that is I've now got 12 different pools of capacity that I can tap into, and the likelihood of me being able to get a spot instance in 12 different pools is very high.
Yeah.
So the higher you make this, the more likely you'll be able to get capacity. I need to grab the target ARN here and stick this into my auto-scaling group.
Saw that.
Again, for those that didn't see, all of this code that is being modified right now is actually available in an open source repo. So the entire process here is not about just hitting one button to have our application, work out of the box to show you this. It's rather to walk you through this example open source repo to see how you can, in your own AWS account using the CDK, configure this same CloudFormation stack super easily and then modify this open source repo to be able to have this work in the way that we're about to show you.
And I posted it again in the chat, by the way.
Yeah,
if you've joined late.
Thank you. Yeah, and the reason that I'm copying and pasting these values in is because I want people to open up the config files and examine what they're doing here and learning what are the details of my autoscaling group config and how can I power it for my application specifically.
And we mentioned before, you know for your application that's a minimum on-demand instance size of 2 to keep the lights on. But other people that may be higher, other people they may be okay with scaling to 0.
Yep.
And desired is 4, meaning that 2 will always be those on-demand, and then it'll try to spin up at least 2 additional spot instances.
Yep. Yep, and so somebody should ask me the question, what happens if I can't get spot instances? Will it use on-demand instead?
I was getting to
I
You
that.
took the
know you
words
were.
right out of
Yep.
my mouth.
Yep. And so the answer to that is no, right? So my request for on-demand and my request for spot in my autoscaling group are unique requests. They do not compensate for each other. They do not fail over to each other. They're unique requests. And I'm saying I would like on-demand for the baseline, and I would like potentially a ratio of spot and on-demand as I scale up and scale down, but never will the two interchange for each other. So I want to make sure everybody understands that about how this environment works.
And then the max, if it ever gets to the max, it's still going to be the same split with 2 on demand and 10. It found 10 spot instances.
Yep. Now, this will scale because I've said everything above on-demand capacity 0. That's a ratio. So I could have said 50, which is a percentage. I could have said make half of my scaled instances be spot and half of them be on demand, and it will maintain that ratio for you as it scales up and scales down.
But you said 0 because you want everything to be spot beyond the first 2.
Yeah, I'm the spot guy, and spot is powerful, and it's going to save me up to 90% off of my autoscaling group costs by using this configuration.
And essentially, one of the best practices I've heard is if you have, again, this like fluctuating workload, and most workloads are fluctuating due to some pattern, regardless of whether it's nightly or monthly or so on and so forth.
Yep.
If you use on-demand and have them configured efficiently such that they're being utilized all the way up to your minimum for like close to full utilization, then all of your scaling up and above that can just be spot, right?
Absolutely.
And so, like those will turn on as needed and they'll turn off, and you know that for all of your minimum baseline, you will always be using essentially a warm instance.
Yep. Absolutely. So I've got my autoscaling group here, and we can see that in looking at the activity history, it did exactly what we asked it. It spun up 4 EC2 instances.
And 2 of them should be spot.
Yep, and when I go over to the actual EC2 console, I can see the lifecycle, and we can look to understand what
Which
these
ones
are.
are spot?
Yep, so if I scroll over, we'll see under lifecycle,
Wow.
I've got 2 spot and 2 normal. I think
Normal
I
is on demand.
Yeah, I always laugh. And one of these is my Cloud9 IDE, or this T2 Micro. But this, what it did was it grabbed the T3 medium, two T3 mediums, because those happen to be the cheapest in spot at the moment.
Yep.
And then it spun up, looks like 2 C4 larges, just
As
like we
the
asked it to.
on-demand ones.
Yep, we asked it to prioritize C4 large for on demand, and we said find the cheapest for spot, and that's exactly what it did.
It's really cool.
Yeah, so let's go look at this load balancer and the target group. So remember, we created a load balancer, and this load balancer is configured, and it has a listener that we set up, and this listener is pointing at the target group. So if we look at our target groups, we can see that I have a target group, and if I look within my targets, there we go. So I've got 4 instances. Remember, these are the 4 that we just looked at.
And if you lose these spot instances and then it has to find 2 others, it's going to automatically swap these targets out.
Yep.
Right.
Yep. So all of these, I have health checks built into it. I'm checking to see on port 80 on slash, do I have a connection? Do I have a 200? And if I have it, my application is considered healthy. So in this case, all of my instances have come up. They've all been reported as healthy, and they've all registered themselves with the target group. So we can actually look at my silly web app here by browsing to the public DNS name, and everybody online can check this out as well. But here's my application, right? So it says hello world. It's reporting its instance ID.
That's a spot.
Yep, and it's reporting that it's
Oh, so it's just going to...
So again, this domain is put in front of the load balancer. You request its load balancer, and then it just determines which of the instances, and it doesn't care because they should all perform similarly because of the launch template. It's an auto-scaling group.
Yes. So the idea here is that it doesn't matter if it's a spot instance or an on-demand instance. The application load balancer is going to route traffic to them as I've asked it to, which in this case is round robin, using round robin across them. But at the end of the day, they're all capable of performing what I need to get done, which is to demonstrate, to spit out some text. However, your application would potentially vary in what it needs to for its environment. And you can select instances that all meet that performance characteristic. And even if it's slightly overpowered, I mean, if you went up to a C4 extra large, it probably wouldn't hurt your app to have a bit more CPU or memory. So you want to think in both dimensions, size as well as family.
I was also going to say, so the first thing that comes to mind when I saw that configuration before with all of those, some of them becoming very large instance types is like, wow, I don't know if I was just using on demand, I would be increasing my costs significantly for something that may not be optimal for my application. However, the entire point here is we're with Spot bidding on spare capacity. And with discounts, being on orders of magnitude of up to what, like 90%, you said?
Up to 90%.
What that means is that you can use the spare capacity on traditionally much more expensive instances and still pay less than the on-demand cost of your traditional instance.
Yep.
And so, this is the real power of Spot. It's not just, get the same performance for slightly less money. You can even get more performance for less money.
I have multiple questions.
Yep. All right.
So going back to Cloud9,
yep.
Where you delineated lowest price, are there any other options that you could be delineating there as the Spot allocation strategy?
So today, this is the primary one within an auto-scaling group.
Like biggest instance, or like if you had another instance that was not around the same size as this, could you delineate a different allocation strategy?
Not today. We are working on additional allocation strategies for Spot specifically to help with this sort of thing. Most customers have told us they want lowest price, they want diversified, and they want a third, which is to help allocate around spare capacity. They want us to automatically find that spare capacity for them.
And are there any instance types that Spot is not available for? Is there any limitation to it?
No. Since you asked, there's only one, which is T2 macro, I believe.
Is not available.
Is not
as
Spot. Yeah, but everything else is, and in all regions. So Spot is everywhere. Even the metal instances are available as Spot.
Wow, super cool.
Please use them. We've got spare capacity everywhere. And the more that you include in this list, the better off you're going to be in your Spot environment, and you're going to save a ton of money by using that. I do want to key off of something you said earlier, which was bidding. We actually got rid of bidding, and I want to make sure that we talk about that here today.
Yeah.
No. I actually...
Things change faster.
Oh, yeah, I didn't know that.
You set me up there. So we actually got rid of bidding in 2017 at the end of reInvent, and most customers haven't realized this yet.
Including employees.
Yeah, so... what we did was customers didn't like the bidding model, right? They thought you had to actually put a bid in to request a Spot instance, and you could outbid each other, and we didn't like that, and we got rid of that whole concept together. So all you need to do now is just say, can I have a Spot instance? And if we have it, we give it to you, and we don't have customers competing against each other anymore.
Yeah, it seems like it just works right out of the box. Like there's not really a whole lot you do besides specify a total number of instances that you need running.
Yes, I didn't put a price anywhere. So
that's what I was going to ask. I was like, oh, where's bidding? And it's like, oh, wait, well, we got away from that. And to that point, again, I wasn't aware of that, but I think this, you alluded to it, but it comes directly from customer feedback.
Yes.
Right? So it's like, we put this idea out here, this service, and we knew that the value of getting cheaper instances was great, but customers spoke to us and said, hey, maybe this wasn't a super ideal, or this was blocking me from getting to use what is otherwise a really awesome product, and that feedback directly translates into changes in the developer experience from the service team.
Yep.
So can you give an example of like one of the instances that you picked, what the on-demand price is versus the Spot price?
Absolutely.
Out of curiosity?
No, thank you for asking that, because I can definitely do that. So if I head over to the Spot console.
So you had a bunch of instances there that were around the same size, like C4 large, and there was T2 medium, I think I saw.
Yep. Let's pick the C4 large here. I'm going to look at pricing history. I'm going to pick C4 large.
And then, so someone else is asking, is it the same price as reserved instances?
Actually, Spot offers a even more steeper discount than RI.
So like comparing to RI on demand and then Spot?
I'm putting it in chat. So on demand is
Yeah.
most expensive, and
Yep,
then
yep.
RI is after that, and then spot is after that.
Yeah, the most aggressive RI will get you, which is I think 3 years all up front, will get you roughly 67% discount. Don't quote me on that. It depends on the instance type. Spot can be up to 90% discount.
Wow.
Right? It's a huge difference. So I'm looking at pricing history for C4 Large, which is what we're powering our app with here, for the past week. In fact, let's go back. I just want to show you how stable prices are. Let's go back 3 months. All right. You can see, according to this graph, spot prices have hardly changed at all, and they only change if we need to change them. They're slow changing. There's no more confusion around spot prices changing in real time.
So
Because there's no bidding.
Right.
So
exactly.
I do a lot of work in AI and machine learning, and so I know that around certain conferences, there would be a huge spike in utilization relative to the typical utilization for GPU instances, and then people would complain. It's like, oh no, like spot instances are now so much like closer to the price of regular on-demand instances, and so now we've done away with that, right? So you shouldn't expect to be able to have prices be really low one day, and then someone spins up a huge cluster, and then the next day it just like quadruples in price.
Right.
Okay.
These changes, the spot prices change in long-term trends of supply and demand instead of immediate.
Okay.
As they used to. So you can see we only change them if we really need to, based on how much strain there is on particular instances.
And I think that this is really important for another reason with respect to like cost planning.
Yes.
Right? So it's not just a matter of like, oh, you save money over on demand or over reserve. But I know that a big piece of confusion before was people having trouble trying to forecast, because even though they're saving money,
Yes.
they still had a hard time because of that volatility. And so now with the much more stable pricing around it, you can perform conservatively estimate a little bit over at the worst case scenario, but customers know what they're going to expect to see here.
Yep. And we can see here we've got low predictable prices. That's exactly what we wanted customers to take away from the new pricing model.
I didn't even notice here actually on the top of the graph you have the on-demand price as the ceiling, so you can directly see exactly what your savings are.
Yep. So when in my auto scaling group, what we've done is you only ever pay what the current spot price is, right? So the on-demand price is up here. This is the most you will ever pay in my auto scaling group, because we automatically cap it at the on-demand price when you don't put in a value.
Yes.
So worst case, you're paying on-demand. Best case, which is what we're seeing here, is you're saving. So it looks like it's roughly 30% of the cost of an on-demand instance. 3 cents per hour versus the 10 cents per hour
Awesome.
that this particular instance type would be. And we can see that this is consistent across different instance types and families and things like that. So another way to look at this is on a page called the Spot Instance Advisor. I'll just pull this up real quick since we're on the subject. This is a page where you can go to look
And
at.
compare every single.
Yep. Let's compare every single instance type in a region and look at two things: savings over on demand, as well as percentages of interruptions that these instance types
that's
have had.
really cool.
Right. So I'm looking at Ohio here.
You can also change the operating system as well.
You can.
I think this is another, like we say it as like a cautionary tale and for you to design around it, but I think like sometimes customers may be afraid. It's like, oh, like I should expect Spot to cancel on a moment's notice at any point in time, and that's not always true. Like we said before, we give a 2-minute
We give 2
warning
minutes,
at the instance level with an event and a CloudWatch event or log.
Yep.
We got a comment. The spot thing looks too good to be true.
I'm speechless.
I mean, it's just
So,
funny at this point.
Yeah. Trust me. Give it a try.
It does look too good to
If
be
you
true,
don't
but
believe
it's
me,
not.
send a message to me and I'll get on a call with you and we can.
I'm
we
gonna
can
drop
together.
Chad's Twitter in
Oh,
the
awesome.
chat
Is that the easiest way to get in touch?
also-
It is. Yes.
because I feel like in case it's it really is too good to be true, you can literally hit him up directly.
So
Do you
this
want to throw
is
the camera back on?
Yeah.
Or-
this
yeah.
is why I love my job. So I get to go help customers. I'm not just helping them save 5%.
Oh, I think it's
like they're saving 80% off of their bill. And this is a lot of money to save. I mean, saving 80% is a lot more than saving 5%. And it feels really good to help customers save significant amounts of money. I know it sounds goofy, but I love helping customers do this. It's the best experience ever.
Yeah, and again, the service EC2 Spot has changed significantly since it was launched.
Yes.
There have been misconceptions about it, and ultimately, like any tool, a developer may look at it and say like, okay, this requires a little bit of work to use, but we saw that there have been huge strides in being able to use it more effectively.
Yeah.
The process of bidding is no more,
Gone.
and we see that even in the you can access so many cost savings and even performance speed ups in some larger instances that you would never probably think to buy or use for the on-demand pricing. But now you can access with Spot for the specific workloads that fit this criterion, and it's just amazing, right? Like there's no other way to be able to access that.
Yep. So take a look at this page. You can see this percentage of interruption is average 30 over the last 30 days for a specific instance
And
type
every
per
single
region.
instance type is listed here except for T2 micro.
Yeah, macros, I believe. It's the smallest
Sorry.
T2, yes. But I never get asked about that with Spot. Customers are typically able
Wanting
to
the
use...
larger ones
Yeah,
anyways.
they're able to use the ones that provide the performance for their application that they need, and above that, right? Because it's cheaper than the on-demand price, they're using whatever they need for their application.
All right, so this is a comment. I kind of want you to speak to this one. So Noble Quimo Shabazz Elbey, wow, long name. Unfortunately, not every application is suited to Spot instance usage from what I read in the doc. So what would be an example of an application that would not be suited to Spot instance usage? Obviously we did a mixed instance host here where you do have on-demand instances at any given time, so your application will be running and won't go down. But is there any application that would suffer from this mixed instance setup?
Configuration.
Yeah, there's two dimensions here, right? So there's anything that is extremely stateful, like a database, does not belong on Spot. Like
Okay.
if I find some of you are going and launching your databases on Spot, I'm going to hunt you down and I'm going to say that's not right. You use RIs for your databases. You
Right.
use something that is persistent, discounted price, but it's not Spot for your databases or anything that is extremely stateful. Other applications that are kind of lift and shift into the cloud can sometimes take a little bit of work to make sure that they're Spot friendly, I'll call it. However, if you make that effort, you're also following other cloud best practices like being stateless, persisting state somewhere else, making sure that you're well architected, diversified, things like that. Now, there are applications that would be hindered. There you go.
If you like the risk, then you can put databases on Spot.
Yes. If you like that, go ahead.
If
but
you like to wing it.
Don't call me and say I put my database on Spot and then it got interrupted, because you will be interrupted at some point. Like that's how Spot works. So
And
make sure
we know that, and we design around that, right?
Yes, it's part of the service.
Yeah. So I can actually give another example of one. So traditionally, very stateful sort of workload is in machine learning. You're performing training,
Yes.
and the joke around it is it's a very long-running task. You set everything up, you press enter, you leave the room, you sleep overnight, you come back, and then 10 hours later you hope it didn't error. But should you have coded everything right, typically, if you were doing that on Spot, it wouldn't really work, because if your application needs to be stateful, and if the instance terminates, then all of your progress and training would be gone.
Yeah.
And now there have been lots of advances in checkpointing so that you can sort of stop and then pick back up. And then recently, actually, there was a really good blog post by one of our coworkers, Shashank, for how to leverage training using Spot with GPU instances.
Yes.
So like you can, again, something that's traditionally very stateful. There have been ways to now offload that state.
Navigate around the interruption.
Yeah.
Or
So offload the state to S3, which is persistent,
and then pick it back up.
Exactly. And so in that launch template, or actually I don't know if it was in the launch template or basically another startup script, but the same idea. Every time the instance starts up, it can pull that last state or that checkpoint from S3, and then the application will just run, the workload will run until training is complete, and you don't have to worry about the instance crashing or it being terminated, rather, not crashing, obviously.
Yep.
Which again is a huge improvement, something that previously wasn't able to be done on Spot. Now can be.
Absolutely. That blog post, I got to work on that with him, and he did a fantastic job of showing how do I take an environment that it isn't traditionally designed for an interruptible platform to be used on it. And I don't know if you saw as well that SageMaker actually recently announced that they're going to offer managed training workloads on Spot.
Yes, so that is something that's near and dear to my heart. I think we might do an episode on that actually, like later on in this show. But I have spoken to customers, and so many of them had said like, wow, SageMaker is amazing. It helps to handle this whole handoff of distributing training across a large number of instances. Now the only thing that they want is, well, they want multiple things, but one thing that they would die for is to have the ability to say, hey, I have this non-time sensitive workload. Can I please use Spot? They love the proposition of it, and it just wasn't available in SageMaker. And so at the New York Summit,
It
on
is
stage,
now.
we announced that it's
It was a pre-announced, but
it was a pre-announcement, yeah.
Yep.
So that will be supported. So everyone who has told me that, I've gone back to you and I've said, hey, this is coming very shortly, and they're really excited for it.
Yep.
Because those are people that would love the value proposition, right? Like if it's not time sensitive, if they can run these these batch processing jobs overnight. I know that's another episode we may have.
Yep.
Spot has lots of really awesome use cases.
Absolutely. I'm really excited about SageMaker. I get asked about it constantly. Can I use Spot in SageMaker? So this is a huge win. We're trying to integrate everywhere. We want Spot to be easy to use in as many AWS services as we possibly can.
We're getting some requests.
Great.
Fargate and Spot, please.
Definitely noted. Definitely a common ask. And definitely we hear you. So definitely I've heard that multiple times, and I'm putting my foot down and saying yes. Let's make sure that we're thinking about this in the future.
Awesome.
One question from Limu: is it worth it to use Spot for a mobile backend?
Yes. I mean, anything that can benefit from some additional capacity can definitely benefit from Spot. So, I have to dig into some of these examples here specifically, but I've heard of many customers that are using it for like a mobile platform or for any of these kind of services. Even media streaming, where you're able to sort of attach and reattach streams to different threads is game.
Essentially anything that requires sort of scalability on the compute side of your application, right? Regardless of whether your front end is mobile or it's just a web app, or
Yep.
You just, let's say you're serving an API, right? Like your own custom API as a microservice internally, you could even have this fulfill that.
Yep.
So
Definitely.
yeah, mobile is totally fair game.
Yep. So I'm gonna go ahead and attach a scheduled scaling policy. Is that okay?
Yeah.
Yeah.
We have
Totally.
Some time for that. Okay. So I've got a pre-config here again called scheduled action. So let's pull this up. Let's see, ASG scheduled scaling. So in this config, what I'm going to do is I'm going to tell the auto scaling group, hey, scale up at a specific time. And it's really useful for like, hey, in the morning I know my user traffic comes at 7 a.m. every morning. I've shut everything down for the night, but I want to make sure everything is ready for all of that traffic. I can schedule scaling to happen automatically in my auto scaling group. So I'm just going to cheat a little bit here and use a website to help me create the timestamp, which helps me put it in an atom format. So let's go ahead and grab this. Let's say we're going to, what time is it right now? Anybody?
It is 3:25.
Okay, so I'm going to say at 3:27, go ahead and scale this up. So I'm going to grab the atom format out of timestamp format here. I'm going to go back to Cloud9. I'm going to place that timestamp in here, save this file, and I am going to apply this scheduled scaling policy here. Let's do this in my Cloud9 environment. Okay, so if I go back to my auto scaling console, which is here in EC2, I can see that under scheduled actions, I have a scheduled scaling, and what I've done is I've said at 3:27 PDT time, please change my desired capacity from 4 to 8.
Ooh,
Right.
and then it would go. When does it go back down?
In this case, I didn't. I could also do a second
end
one that
time?
would not an end time, but I could create a secondary scheduled scaling to reverse that. It
Got
would
it.
go back down. This is a one-way, just for demonstration purposes.
So a great workload that comes to mind for this in particular would be like, let's say I know that let's say like you have an online retailer that has a scheduled release of something at a given time that they have announced.
Yep.
You could just leave it up to auto scaling, or you could say, okay, I know that at noon at this time this is going to happen, so please 10 minutes before preemptively scale everything up.
Yep. Yep. And this way you're ahead of the game. You know you have predictable traffic patterns, and so this way you can not leave anything to guess and just allow it to scale up itself whenever you're ready for all of that traffic to come.
Great.
So let's see. This should get triggered here any moment now as time goes on. And while we're waiting for that to happen, I want to kind of look ahead a little bit and look at the next section, which is around scaling dynamically. And so in this situation, what we're going to do is we're going to apply a scaling policy that will use target tracking. And target tracking is a method to say, hey, auto scaling group, go figure out how much capacity I need for my workload. So it will happen automatically. So I'm going to pull this config up and take a look at it. And this config is called ASG automatic scaling. And this one is quite simple. So this one has a policy name and a policy type, which is target tracking scaling. And it's allowing me to tap into a predefined metric. I can also make my own metrics. But in this case, I'm going to ask for average CPU utilization to be no more than 50, right? I want to make sure that the aggregate CPU utilization across my auto-scaling group is no more than 50. And the auto-scaling group and the CloudWatch alarms that will be created from this target tracking policy will automatically add and subtract capacity to keep me at this value. So let's take a look here. I'm going to go back and take a look at my CloudFormation stack, my auto-scaling group, and look at the history. All right, so looking at my history, we can see that I successfully executed the scheduled scaling policy, which added 4 more instance types to my auto-scaling group. So I now have 8. So if I refresh here, we can see I now have 8 instances in my auto-scaling group.
Because it worked.
Yep, it did work. And if I go back and look at my instances, we can definitely see that these are spot instances, right? So spot.
Warstomp, do you use machine learning to predict traffic to best allocate resources?
There is actually the ability to create a scaling policy in an auto-scaling group that uses machine learning called predictive scaling. And predictive scaling will look at historical metrics for your auto-scaling group and apply policies that will automatically adjust and add and subtract capacity based on what we've learned from historical patterns in your auto-scaling group.
And again, you don't have to perform any training on that. That's all automatic.
Nope. Yep. It just takes history of your auto-scaling group and applies machine learning to that, and then sets up appropriate policies for you automatically. So I'm going to go ahead and apply this this automatic scaling policy. I don't actually have to make any changes to the config because it's already ready for me to go here. But what I'm going to do is I'm going to apply this policy, and we can see that it automatically created CloudWatch alarms for me, and it automatically set the policies up for me and attached them to my auto-scaling group. So if I go back to my CloudFormation template, if I go back to my auto-scaling group, we can see that I now have a scaling policy attached to it that will add and subtract capacity to my auto-scaling group, desiring to maintain a CPU utilization of no more than 50. So this is the CPU load on each of the aggregate CPU load across my entire auto-scaling group.
And this can be valuable where, like, if you know that your application is bound by a particular type of resource, either CPU or by like memory or disk, I don't foresee disk being the issue here, but if you know that above, let's say, like 80-90% utilization, that things get a little dicey, you may want to set that average number to be a bit lower so it can auto scale preemptively.
Yes, this was an arbitrary value I picked because what we're going to do next is simulate load on our app. So that we can trigger this alarm.
Get to 50.
Yep. And so what we want to look at here is that the auto-scaling group, this policy should actually detect that we're over-provisioned, right? Because we're running 8 instances, but our CPU load is going to be relatively low because we're not actually using anything on the app. Yep, unless the whole world.
Well, we could give the link to Twitch and they can go wild with it.
We could do that.
You guys want to do that? You want to help us load test?
Yep.
Be our Amazon Mechanical Turk for DDoSing.
Yeah.
For our demo here.
We could do that. Should I paste it to you?
Yes.
Would that be useful? All right.
All right, chat. We need your help. We're gonna give you a link. We want to have you help us simulate demand for this instance, for this this application.
Yep. And I'm gonna do it too using SSM, but we'll just do this here. Okay, got that,
Alright, let me give it to chat. Okay, guys. Go wild.
Yeah, use your best.
Ping it 1,000,000 times.
Yep.
Open incognito, ping it again, open every browser
Or
you
just
have.
like
use
curl
your
it in a
phone.
terminal and just keep
Yeah,
clicking
write
enter.
a while loop and curl it.
I'm gonna help out a little bit.
And what we'll see here is that the policy that I put in place here will actually start to remove instances from the overall auto-scaling group, and it's going to take a few minutes to actually remove them. And I don't actually have to wait for that to happen, but we can.
Trying.
The metronome you're hearing in the background is Nikki curling the endpoint a bunch of times.
I love this.
I mean, this is kind of fun.
I'm sitting here spamming refresh. I keep seeing the instance type changing. So
Yeah. So while everybody's pounding on this this application load balancer,
Guys, are you actually helping us out? No one said anything. Are you curling or hitting
they
this
can't type because
endpoint?
they're hitting.
yeah, they're busy.
Yeah, they're busy actually like just hitting it 1,000 times.
Yes.
Just someone let me know, like emoticon or emoji or something like that you're actually doing it. Refresh button worn out.
So what I'll do is I'll go ahead and start some simulated load while you are all pounding on the web server anyway, to help out with this. And what we're going to do is we're going to use.
Oh, I'm not getting a response anymore.
nice.
It's slower.
Very nice.
You guys are doing good. Keep up the good work.
So I'll add to the fun here. I'm going to use AWS Systems Manager to add some additional stress. So I've got this config.
Yes.
I've got this config called SSM stress, and what this is going to do is it's going to use the tags that we applied. Remember in the launch template we attached tags to each instance, and this tag, which I've called env for environment and the value of prod, I'm going to use it to single out which instances to put stress on, and we're simply going to run the stress ng command for 15 minutes through this SSM command.
Let's do it.
Let's do it,
so
right?
Excited.
So it is pretty exciting. So so let's go ahead and do this. I'm going to grab my command here and execute it in my Cloud9 environment. All right, so it's set it up. We've set it off. I'm going to go back to my auto scaling console and just look to see if any magic is happening here yet. So the auto scaling group is actually removing capacity right now because remember this policy we put on it noticed that we're actually over provisioned, and it's actually decided to start removing instances, so we're not putting enough stress on it to actually keep it at this. So the auto scaling group is actually draining one of the instances already, so we can see it's changed from 8 instances to 7 desired, so it's removing one. But now that we've actually set up some stress on this, and let's go take a look at the.
Keep going, guys.
Yeah, let's go take a look at the SSM console. AWS Systems Manager. If I look under the run command, we can see that I have a command already being executed, which is that SSM command that we just sent, and it's targeting 8 targets. And those 8 targets are those instances that were a part of our auto-scaling group. So we're running the stress command on each of these, and it shouldn't take too long for enough stress to be generated on each of these instances to set the aggregate CPU load over 50% across the entire auto-scaling group. So let's go back to our auto-scaling group and take a look and see how it's doing here.
Moment of truth. We'll see how strong the power of Switch Chat is, and our
Guys,
tool that
how
we're
you
using.
doing?
So
Did you take down the site yet?
So the auto-scaling policy, the target tracking policy, noticed that we were over-provisioned, and it actually started subtracting instances for us automatically.
Wow.
That's how it was supposed to work. So it's telling us, hey, you had 8, but you don't need that much to have a 50% CPU utilization. But in a few moments, since we're stressing the instances themselves, this will reverse itself, and will actually start to spin back up and add capacity back to our overall.
My hand hurts.
That's funny. And we've set a maximum of 12. So after it spins back down, we should see some instances starting to be added back into it. We'll see those alarms triggered, and those will start to add capacity.
I'm also just like continuously pinging it.
Thank you, Nikki. That's really
Helpful.
it is.
Don't worry, Twitch. If you get tired, I got your back.
Yep. So while we're waiting for this to happen, are there any outstanding questions that you guys saw that I missed, or I can clarify?
So I mean, this was less of a question. So it was a question that was answered in chat, but I think it's nice to bring up. So we were talking before about how predictive auto scaling helps to, based on your historical data, use machine learning to understand when would be best to perform that auto scaling.
Yep.
And so someone asked before sufficient sample size is acquired, like let's say a new set of workloads, is it reactive? How does that work? And so the answer that was thrown around in chat is that for predictive scaling, the blog post says that the model needs at least 1 day of historical data to start making predictions. So pretty soon, pretty early in the process to be able to use that.
Yep.
And it's reevaluated every 24 hours to create a forecast for the next 48 hours. And there's more details in the blog post that was linked in chat. Is there any color you want to add to that, or is that pretty comprehensive?
No, I think that's a great answer. I'm glad somebody looked it up. I'm always amazed at how little they need to actually make some good predictions for that automatic scaling. I'm a huge fan of EC2 auto scaling, as you can probably tell. They're working really hard at making sure that all those features that our customers are asking for are being added. And just like you might have feature requests for Spot, I can also take feature requests for auto scaling. So for those of you out there that are fans of auto scaling groups, don't be shy. Hit me up on Twitter, and I will make sure that those are listened to and heard. And we want to know what we should build for you.
Wonderful.
Should I post his Twitter in chat again?
Yeah, let's
Done
throw
it
it
a
back
couple
in there.
times.
Thank
But
you.
yeah, hit him up.
Yep. So this is really it. I hope that we've been able to show how easy it is to add some Spot into your infrastructure.
And let's just say shameless plug. Like, we will have you back on the stream.
Thank you.
We're gonna do EC2 spots, several of them, right?
Yep.
About different ways to use EC2 Spot in different use cases. And I believe the next one will be sometime at the end of August.
So we chat has loved you as guest, but I think we hinted at some of the other workloads, for example, that we'll have in those future episodes. So today we spoke obviously about some sort of dynamically scaling compute backend for your application, whether that's a mobile front end or just another microservice internally. Does not really matter.
Yep.
That any sort of scalable compute for a web application fits into today's use case. Again, we have a GitHub repo with all of the code that we've used today.
Yep.
Looks like we got a final question.
We do have a final question. So Twitch Ganesh is asking, can we talk for a few minutes about dealing with interruptions? So I know we've talked about this before, but it was early on in the stream. So again, with EC2 Spot, you have can't use the word instances again, and unit of time and objects. It gets confusing, but there are scenarios in which your instances will be terminated. And so we mentioned before that there is a 2-minute notification that gets sent out both at the instance level, so that can be detected by your application code as well as on CloudWatch logs. So with that event, how can developers program around termination to help get around that? So obviously removing state or storing it elsewhere.
Future stream
and how can they deal with interruptions, basically?
Sure. So the two ways we tell you you're going to be interrupted are on the local instance and externally in CloudWatch events. If you want your application to be interruption aware, you want to use the local metadata, because your application can then be told, hey, you're going to be interrupted, save your state, copy data to S3, do something local on the instance that's relevant to making sure that the interruption doesn't affect you.
Because you still have 2 minutes.
You still have 2 minutes. It's a lot of time. I equate it to like 2-minute warning in a football game. That ends up being like an hour.
Yeah.
You can get a lot done in that 2 minutes, and it's really useful. So make sure you take advantage of it. If you want to do something externally, like let's say you want to detach from a load balancer, you want to drain containers, you want to do something that is not local to the running application, but to your overall application. Thank you for refreshing still, by the way, everybody. If you want to do something external, it's working. Look, we've spun up to 10 instances already here, so everybody's doing a great job generating load on our web application. That's awesome.
Nice job, guys.
Yeah, thank you, everybody. Look at those spinning up. If you want to do something external, again, drain containers, drain connections from load balancer, put a job back in an SQS queue in some other message queue, use the external CloudWatch event. Those are both important tools to use when it comes to handling interruptions. Now, I left something else out earlier, which was there's actually 3 different things you can tell us to do when an interruption occurs. And those 3 choices are terminate, stop, or hibernate. So you can actually tell us, rather than terminating an instance, you can tell us to stop the instance just like you would stop an on-demand EC2 instance. And when the capacity returns, we will automatically turn that instance back on for you.
Oh, cool.
Yeah, so it's not like it has to be terminated. You can tell us to stop the instance. You can also tell us to hibernate, which is actually suspending memory to the local EBS volume. So it's like closing your laptop lid. We will automatically close that laptop lid for you.
So it saves the state.
Yep, saves the state.
Well, so stopping the EBS volume will persist, but the in-memory state will not. But in
Correct.
hibernate, both the EBS volume and the memory state will persist because it's pushing the memory onto the EBS volume.
Yep.
So depending on, again, like,
That's
statefulness
really cool.
is not always now even, binary, right? It's like, is it going to be saved on disk in EBS, or is it going to be in memory? And if you can benefit from pushing that from memory on shutdown to volume and just hibernate, that's another option for you.
Absolutely. So we want to make sure that customers are.
So
are able
can
to do
you
that.
possibly, on a future stream, show a few ways of dealing with the interruptions?
Absolutely. I would love nothing more than to do that. So,
Twitch Ganesh, we are going to do that. for
yes,
you.
I will definitely do that. I have some example code. I have a blog post on this, taking advantage of interruptions, and I'll walk through the whole thing with you, and look at doing it locally as well as externally and as a CloudWatch event. So, great.
He also says he read somewhere that Spot did not allow stopping.
So, it's not something that a user can control. To be clear, the stop and the hibernate are both controlled by EC2. So we
Okay.
will automatically stop your instance, and we will automatically resume or restart your instance
But you
for you.
delineate which one we want you to do, or?
Yes. When you request a spot instance, you can tell us which interruption policy to apply to that instance.
Got it, so there you go.
Terminate, stop, or hibernate.
Wonderful.
Not user controlled though, controlled by EC2.
Right.
Great. Well, I think if that about does it for the questions in chat, a lot of people are singing their praises, so they've definitely enjoyed the stream. But Chad, thank you again for everything.
So
Thank
we
you.
will be back.
I don't know if the
Yeah.
camera is working, so
The
yeah, the
camera
handshake.
the
but
camera is still not working, so sorry
yeah.
guys.
Fighting a little
you know,
against the
Black
elements
screen
today.
is really where we're at right now. So
Okay.
we're not going to switch back to the camera. I just did it for a second. But we will be back with more EC2 Spot at the end of August. Follow us on Twitter. We will post about it a week preceding. I'm not sure on an actual day yet, but I know it'll be the end of August. So please stay tuned on our Twitters to see when Chad will come back and show us some more awesome stuff with EC2 Spot.
Yep.
Thank you very
Thank
much.
you so
I'm
much
going
for
to shake your
having me.
hand too.
Yeah.
The invisible handshake to the
Nobody's
camera.
actually seeing anything, but
Uh,
you know.
That's all good. Thank you again, everyone, for tuning in. This has been the episode 1 of our new series on how to save money and increase performance through EC2 Spot. We're glad you enjoyed it, and we're excited to see you again in about a month's time.
Yep, we will see you guys at the end of August.
All right. Thanks again,
Thank you very
everyone.
much.
Thank you, everyone.
We'll see you soon.
Take care.
Bye.